Module 9, Lesson 5 covers the surface area of a three-dimensional figure. Our pacing guide says it's going to be a 90-minute lesson. There's only 13 resources in it, but I think these resources may take us a little time to get through because we're going to have to find the area of a lot of different pieces parts in our polyhedrons. Have you ever had the opportunity to decorate your room? One of the hardest decisions to make when designing a new room can be selecting a paint color, determining how much paint is needed. Most of the time, paint is sold in a 5-gallon container, but it can also be sold by either a quart or a 5-gallon bucket. It's sold in a 1-gallon container. So you've got 3 different sizes, and you only want to spend so much money, right? So you don't want to buy 5 gallons worth of paint when a quart's going to get the job done for you. Suppose you decide to paint the bedroom a new bright color. The paint is in a gallon container, and your room is shaped like a rectangular prism, where you have 13 foot long and 9 foot wide walls, and the walls are 18 feet tall. How you know you will need 2 coats of paint? What will you need to know in order to determine how many containers of paint to buy, and what other information do you need to know? These are the kind of questions we're going to be asking in today's lesson. The sum of the areas of all the surfaces, also known as faces, of a three-dimensional figure, and faces is going to be a vocab term, is going to be its surface area. And if you highlight that whole thing is going to be the actual definition of surface area. And I'm going to see the faces got double highlighted. When you find the surface area of a three-dimensional figure, the units are always going to be square units. To find the surface area of a rectangular prism, you have to find the area of each face and then calculate the sum of all the faces. It says move through the slides to see how you can add the area of the prism's faces to find the total. Now this little drawing over here, this is what we call a net, and your instruction says to make a net, and a net is where you have folded that box out flat, laid it out completely flat, cut along all the seams of it, and then ended up getting this nice flat 2-dimensional representation of this 3-dimensional box. So to make the instructions from there say to find the total surface area, first thing you do is start finding the area of different parts. So right there you have one section that is 8 meters wide and 7 meters tall, and actually 2 of those sections, and you're going to have to show you big kid math on this, and we'll talk about that in a little bit, where you find the area of that, which is 56 meters. Next, they took and found the area of this 6 meters wide and 7 meters tall, and that matches this one here as well. And then finally, they found the area of the top and bottom that was 8 meters wide and 6 meters tall. All they had to do after that is add those up, and when they did, they found that the surface area of that prism is 292 meters squared. If you have pieces that are the same, you only have to work them once. So for example, the 8 by 7, you only had to take and do the math on that one time, and it fit both of them. You notice they also wrote those numbers inside the shape on the net. I strongly encourage you to do that. Now here they've given us a rectangular prism, and they want us to find the surface area of it. Of course, the first thing we're going to do, just like we've mentioned before in the last one, is we have to make a net of that figure, meaning we have to lay it out flat in a way that it could be folded back up properly, where all the side lengths are correct. So to do that, let's see how they're going to do it. They say to find the opposite area of the opposite pairs. They're actually not making a net. Make a net is better. So you can see you have these 2 are opposite pairs. These 2 are opposite pairs, and these 2 are opposite pairs. And from there, we need to take, and what are we going to do next? We're going to find the sum of them. Wow, I just really don't like what they're doing. So we're just going to take a break back. They're overwhelming you with too much. And I'm going to take a picture, and we're going to go a little old school, make our net to do this the proper way, and show all of our work. Stand by. Okay. So I need to start off by making parts of my net here, and I'm going to start off with this big wall right here. And that big wall right there, I'm going to draw like this. And then I have a tall, skinny wall behind it, which is going to be that. And that's going to be this wall back here. And then I have another big wall. Yeah, I know my lines aren't pretty. Get over it. I'm a math teacher, not an artist. And then that's that wall there. And then this skinny wall right here, I'm going to put like that. Next, I have a top. And my top, I'm just going to put right here. And then I have the bottom part. And that bottom part, I'm going to put right here. Now I have to label it all in such a way that it will fold back up properly. So the height, that's going to be 13.6. The base of the long section was 9.25, and we'll put that there and there. And the base of the skinny section, that was going to be 7.5, which I'm going to put here and here. Now the next thing we have to do is we have to find the area of each one of those pieces. And I'm going to take and start off with that big rectangle on the left. And I know the formula for area of a rectangle is going to be length times width or base times height. So area is equal to, I'm going to have a length of 9.25 times a width of 13.6, which means the area of that is going to equal to, let's grab ourselves a little calculator here. We're going to do 9.25 times 13.6, and that's going to give us 125.8. So from there, I can take and put that in as 125.8, and I'm also going to write that here, and I'm going to write it here. That helps me to keep track of what I've done and what the sizes of those rectangles are. Next, I'm going to do the next pair of rectangles. I'm going to write my formula again, which is going to be area is equal to length times width. Area is equal to, I have a length of 7.5 and a width of 13.6. Come back to our calculator. So now I have 7.5 times 13.6. And when I do that, I get area is equal to 102. 102 and 102, which I'm going to write into those rectangles. Finally, we have the top and bottom to do. It is a rectangle also, so I'm using my same formula. Area is now going to equal to, I have a length of 9.25 and a width. This side and this side meet up together, so that's going to be a width of 7.5. And when I plug that into my calculator, 9.25 times 7.5 equals, we get 69.375. And I can put that here, 69.375, and I can put that here, 69.375. Now all that's left to do is add all of those up. So I'm going to do that with two of them that are 125.8. I have two of them that are 102, and I have two of them that are 69.375. Now I'm going to annex in some decimals and zeros here in order to get everything to line up nicely, and then we're going to add those up. So adding them up, I'm going to get a 10, carry the 1, 15, carry the 1. Now that's going to be 16, 23, carry the 2. That can give me 16. From there we have 25, 34, carry the 3. And now I'm going to get, let's see, that would be 12, 13, 14, 15, 16, 19. And the decimal comes straight down. So rounded to the nearest hundredths I place is going to be 194 and 35 hundredths. The textbook wants us to take, and how did they end up working it? Let's take a look. They ended up getting a different answer. Let's see what we did wrong. Start off by just adding them. 125.8 plus 125.8 plus 102 plus 102 plus 69.375 plus 69.375 equals, yep, somewhere I had bad math in there. I didn't carry something properly, and that's the reason that 1 should be a 5. So we did get the same answer they did here. I don't really like the way they're doing it. It's much smarter. Make a net, draw it out. It'll help you keep track of your shapes. Now it's going to be your turn. Go ahead and pause the video and make a net of this shape. After you make a net of it, find the area of each pieces part, and after you find the area of each pieces part, add all those pieces parts up together to find out what your total area is going to be. Now the first thing I'm going to need to do in my net is I'm going to take and make those big rectangles. So you can really start at any point, but that's the point I want to start with. So I have a big rectangle that is 8 2/3 by 10 1/3. And then I'm going to do this side right here, which is going to be a skinnier side, which means I'm going to have a 3 1/6 for that side, but it's still going to be 8 2/3 this way. I'm going to put in another one of the big rectangles here, which is going to be the 10 1/3. Yes, I know they're not the same size. And another skinny rectangle, which is going to be another 3 1/6. Finally, we're going to put in the top right here, and we're going to put in the bottom right here, and these of course are going to be the same, 10 1/3 that way and 3 1/6 this way. Now that I have my net made, I can start putting in my formulas. I have 3 different size rectangles, so I'm going to need to work 3 times. First one, let's go ahead and do the big ugly one. We do 8 2/3 times 10 1/3. When multiplying fractions, you have to change them to mixed numbers. 3 times 8 is 24, plus 2 is going to be 26 over 3, times 3 times 10 is 30, plus 1 is 31 over 3. From here, we could try and simplify things. And let's see, will anything simplify? No, it won't. So now I'm going to take and grab my calculator to make life a little easier for us. 26 times 31 is going to equal 2, so I have 806 over 3 times 3 is 9, and that one is going to be put here. 806 over 9 and 806 over 9 again. Your textbook really does like to give you some unfriendly numbers to work with. Next, I'm going for that skinnier rectangle beside it, which means I'm going to change my color. Area is equal to length times width. This is the width one I'm working with, so now I have, it's going to be the same 8 2/3 tall times a width now of 3 1/6. That means I'm going to have the 26 over 3 for that one, times 6 times 3 is 18, plus 1 is 19 over 6. Can anything simplify here in this one? Once again, the answer is no. Nothing's going to simplify. Actually, yes, we do have simplifying. 2 goes into 6 3 times. 2 goes into 26 13 times. And now we're going to take and multiply that. Grab our calculator. 13 times 19 is going to equal to 247. 247 divided by 3 times 3, that's going to be 9 again. So at least so far we have a common denominator. And now it's time to do the last rectangle, which is going to be the same formula. Area is equal to length times width. So now area is going to equal to, I have a length on this one here of 10 1/3, and I have a width of 3 1/6. Change those to the improper fractions. That's going to give me 31 over 3, and the 3 1/6 we found was going to be 19 over 6. And this one, sadly, is not going to simplify, and that means we're not going to be able to keep 9 as a common denominator, but our denominator is not going to be too bad. So I'm going to do 31 times 19, I believe my answers were, which is going to be 589. Over 3 times 6 is going to be 18. And that I'm going to be putting here, 589 over 18, 589 over 18, and I just realized I did not put my reds in, which was 247 over 9, and 247 over 9. Now comes time to add them all up. So I've got 806 over 9 plus 806 over 9. Those should really be blues. Plus my reds were 247 over 9 plus 247 over 9. And then my greens were going to be 589 over 18. Move our table to the side a little bit. Plus 589 over 18 again. Find that least common denominator, which is going to be 18. So I have something over 18 plus something over 18 plus something over 18 plus something over 18, and plus these will stay the same, 589 over 18 and 589 over 18. Now we're going to have to double the ones up above, so 806 double, that's going to be 1612 and 1612. And then 247 double, that is going to be 480, 594. No, 484. Hold on. 484, 94. Get my numbers right here. 494 and 494. Now we're into some serious calculator time, so bring my calculator back up, and that's going to give me 1612 plus 1612 again, plus 494 plus 494 plus 589 plus 589 equals, so I have 5,390 over 18. Now I'm going to go ahead and just use a calculator to help me get my start on that. So I'm going to take and divide that by 18. Maybe we'll get lucky and it'll be perfect, and it will not. So I know I'm going to be dealing with 299 and some mixed number. So I'm going to put that in a house. I'm going to say 5390. Whoop, put that in the wrong spot. Divided by 18. And I know I'm going to have 299 is my starting point. 2 times 18 is going to be 36. And then when you subtract that, you do some borrowing. 13 minus 6 is going to be 7. 4 minus 3 is 1. Bring down the 9. And then 9 times 18, that's going to become 90. Plus 72 is going to be 162. If I did that right in my head, subtract that out, you get 17 left over. Bring down a 0, and then you're going to do that same thing again, 162, and then from there you're going to end up getting an 8 left over. So that means our answer is going to be, put a line here, 299 and 8/18, which is also known as 299, and 2 goes into 8 4 times, 2 goes into 18 9 times, 4 ninths. Let's see if we got that problem right. Come back over here, plug in what we came up with, 299 and 4 over 9, accept, and hold your breath. We got lucky on that one. No, we didn't get lucky. We got smart. We did good. Alright, that's going to be it for part 1 of the video. Come back and watch part 2 where we continue our study of surface area of prisms.